Psychoacoustic measurements methods. Psychoacoustic measurement methods, hearing thresholds, dB, SPL, dB, HL, dB, SL, dB sound pressure level, dB hearing loss, dB sound level, psychometric function, classical adaptive constant stimuli, up, down, and transformed up, down, absolute and differential threshold, signal detection theory, ROC curves, Weaver fraction, power law, a lot of things here. Basic psychophysics. We have a stimulus and a listener called in a black box called call it C, and a response. Goal to determine the function C, where the response F is a function C of stimulus I. The absolute threshold is the lowest level of stimulus I that produces a reaction at the response instrument. The lowest stimulus that make a response. Okay. Then there is a differential threshold, the smallest change in the stimulus delta I that produces a change in the reaction delta F. Or it's we can also call it just noticeable difference, just noticeable difference, JND. Okay, stimulus and a listener and a response. The active test subject variability in data, repetition, statistics, special measurements methods, and we have to reduce number of repetitions because of the low down the limit the test time and reduce noise. We also have we have some types of tests: threshold experiments, balance experiments, scaling experiments, and task experiments. We have the absolute threshold experiment. And now it's about differential threshold frequency, JND experiment from last lecture. Second tone is either higher or lower in frequency by some delta F. Could be up or down. Yes. Then we have a balance. We have the normally hearing threshold curve, but threshold curve for normal listeners, and we see that the minimum is about 3,500 hertz, the resonance frequency, and it grows is going higher at higher frequencies and lower frequencies. We have some balance experiment. We have some sound measured in phones and 1 kilohertz tone. So we have to find out how many phones is the sound. Yeah. And I come back to this. I come back to this so-called equal loudness contour later. Loudness rating methods. Yeah, you can say that at one, if you have poor tones at 1,000 hertz, the decibels, the SPL value of this 1,000 hertz sound is the same as the number of the phones. Yeah, but the decibel sound pressure level will vary if you are deviating from the 1,000 hertz. Then we have the loudness rating method. Loudness rating methods. It's kind of scaling. Yeah. You have a reference assigned an arbitrary loudness value, for instance 100. The probe listener responds with number corresponding to his or her perception of relative loudness. For instance, 50 is a half reference, 200 if double. Okay. And then we have an example of a task. Temporal integration from last lecture. Count the number of steps you hear in each case. Yes, it could be that this decibel is decreasing. We have some hearing threshold. We have the classical on-off threshold, where you so-called psychometric function, and that we want to find the level in dBs where the percent is 50. Yeah, and so we also have data from real experiments, and we can define the threshold of, for instance, 50% or 75% or 70% maybe. Okay, psychometric functions, assumptions often assume a parametric form. For instance, parametric form, cumulative Gaussian or logistic function, for instance. Monotone. That would say percentages of yes always increases. Is a monotonic increasing. Function is time invariant, no change in shape or position or course of an experiment. Responses are independent of previous presentations. We have some methods for measuring threshold. Classical methods of limits, Big Kissy method, Ascanting method of constant stimuli, that's called classical methods. And then we have the adaptive method, simple up-down method, transformed up-down method. Okay, this classical and adaptive. Yeah. Yeah. Classical and wait a minute. Classical and Ascan. Yeah. Methods of limits. Approach threshold from both directions. From well above, you have a loud sound. You have to say yes or no. Decrease until a no response. From well below, when yes, and no. And then from well below, increase until yes response. First, well above, increase until no response. Yes, no. And from well below, increase until yes response. No. Yes. Threshold is average of the limit values average of the limit values, and it is about a threshold is 50% on the psychometric function. Yeah. Yes, we're continuing this a series of number of limits. Then we have the Casey method is something about keeping the bottom as counting methods. That means you have modified a version of limits. Start well above threshold. If yes, then decrease by a large step, for instance 10 dBs. Then it comes to no, then increase by a smaller step, for instance 5 dB. Stop criteria is when 3 ascending responses at the same time. At some same level. Stop criterion, 3 ascending responses at same level. A method of constant stimuli. Pick a range of levels. Pick a range of levels. It's directly measure a response at each level. Usually, presentation sequence is random. So you, for instance, have how many you have a relative level of 6, relative level of 6 dBs, then 3 answered, okay, and 4 dBs, 3 answered, 2 dBs, 3 answered, 0 dB, 2 answered, and so on, and so on. Yeah. Okay, and it takes time, this. Yeah. And you can make you can draw a psychometric function from the stimulus. Count number of positive responses at these levels. Then we have adaptive methods. The course of a test is determined by the data obtained during the test. Stimulus level is dependent on the response from your previous presentations. Okay, adaptive. Time efficient. Focus on a threshold instead of an entire curve. Possible to avoid presentations where the response is almost certain beforehand. It's computer controlled. Simple up-down. Similar to both the method of limits and Bekesi method. Okay, limit. Need 3 things before start. Step size, start level, pick a step size, and stop criterion. If yes, start. If yes, then decrease level by 1 step. Yes. If no, increase by 1 step, the same step, up as in down, then down. Example stop criteria 8 reversals. 8 reversals. Okay. Yeah, 8 reversals. Okay. Where will we end on the curve? If we have a simple up-down, then for equilibrium, P down, the probability of down is the same as probability of up. And the sum of the two probabilities is 1. You can say probability of up is 1 minus P down. So for equilibrium, P down is a half. Since P down is a P yes, P down is the same as P yes. So we have for equilibrium, P yes is 1/2. Yeah, and then for P no is also 1/2. Yes. Yes. So simple up-down level depends on previous response. Transformed up-down level depends on 2 or more previous responses. It could be 1 up, 2 down. Increase level after low, decrease level only after 2 years. 2 years, yes. Yeah, okay. Then 2 years, yeah. So a convergence for 1 up, 2 down. For P down is 1/2, and P down is the same as the probability of 2 years in a row. That means that P down is the square of P yes. Then P yes must be the square root of 1/2. So probability of a yes is the square root of 1/2 is almost 0.7. Thank you.